Solve. 3 to the 2x minus 1 is equal to 2x plus 1. All right, in order to solve this, we're going to apply the ln to both sides because we cannot rewrite 3 and 2 so they have the same base. So we'll take the ln of the left and the ln of the right. So ln of 3 to the 2x minus 1 power is equal to ln of 2 to the x plus 1 power. The 2x minus 1 can come down now as a coefficient along with the x plus 1. So we'll end up having 2x minus 1 times ln of 3 is equal to x plus 1 times ln of 2. Then from there, we're stuck distributing in the ln of 3 and the ln of 2 because we want to isolate the x, and the only way to separate it from those numbers is to basically remove the parentheses by distribution. So we're going to go ahead and do the distribution here. So it'll be 2x times ln of 3 minus 1 ln of 3 is equal to, here we'll have x times ln of 2 and then plus ln of 2. All right, now we want to bring the pieces that have x connected to them together on one side and bring the numbers on the other. So I'm going to bring this ln of 3 over here, and I'm going to bring this x ln of 2 over here. So that will end up giving us 2x ln of 3 minus x ln of 2 is equal to ln of 2 plus ln of 3. So remember, the negative ln of 3 becomes positive on the right-hand side, and the x ln of 2 becomes negative when it crosses over to the left-hand side. From there, we're going to go ahead and factor out the x that's common to both pieces on the left. So we'll pull out the x out in front, and we'll be left with 2 ln of 3 minus ln of 2 is equal to ln of 2 plus ln of 3. And then lastly, we need to divide both sides by the 2 ln of 3 minus ln of 2. So if we do that, we have that this is equal to x. You can actually rewrite this a little bit if you want. It's up to you. Whenever you have something like that, the ln of 2 plus ln of 3, you know that you could rewrite it so that you have the sum become a product. So you can change that to ln of 6 if you want to keep it simpler. And then for the bottom, remember the 2 can come up here on the 3, becoming an exponent, making it ln of 9. So you could do ln of 9 minus ln of 2. If you like that, if you think that's simpler, that's perfectly fine to do. I don't know, it's up to you. Either one is the answer. Both are equivalent, so it's just a matter of saving a keystroke or two in your calculator, but essentially they're the same. All right, let's look at example B then. For example B, same thing, we're going to take the ln of both sides. So if I do the ln of 5 halves to the 1 minus x power, that'll be equal to ln of 4 to the x power. Then I can bring down this exponent of 1 minus x, bring down that exponent of x. So I have 1 minus x times ln of 5 halves is equal to x times ln of 4. Then we can distribute in the ln's, so we'll have ln of 5 halves minus x times ln of 5 halves is equal to x times ln of 4. I'm going to bring this guy over to the side so that it becomes positive and so that the x is joined with the other x, right? So to get the x's on one side of the equation. All right, and then from there, I have that ln of 5 halves is equal to x ln of 4 plus x ln of 5 halves. So I can pull out now, if I want, the x that's common to both sides on the right, right? Sorry, to both terms on the right. So I end up pulling out the x, and I end up with ln of 4 plus ln of 5 halves. Then divide both sides by that piece to give me ln of 4 plus ln of 5 halves. So on the right, that cancels out, leaving you with just the answer that x is equal to ln of 5 halves over ln of 4 plus ln of 5 halves. And again, if you wanted to simplify this a little bit, you can rewrite that as ln of 5 halves divided by the 4, and the 5 halves can multiply to make it ln of 10. And again, it's ln of 10 because 4 times 5 halves is 20 halves, or 10. And then if you don't like fractions, remember you could even take the 5 halves and turn it into what? ln of 5 minus ln of 2 over ln of 10. All of these are the same, right? So this answer, this answer, this answer, if you evaluate them in your calculator, you will see that you get the exact same answer either way. So those three rewritings are just basically practice with your log properties, right? Remember that the difference of two logs with the same base can be expressed as a quotient. The product of two logs with the same base can be expressed as a product. That's basically all we've done. All right, let's look at C and D then. All right, so for C and D, it's the same kind of thing. We're going to take the ln of both sides. We'll go through this pretty quickly here. So ln of 0.4, 2 plus x is equal to ln of 1.9, 3x minus 1. So the 2 plus x comes out in front. The 3x minus 1 comes out in front. You end up having 2 plus x times ln of 0.4 is equal to 3x minus 1 times ln of 1.9. Then you distribute, so you end up with 2 ln of 0.4 plus ln of 0.4x is equal to, distributing here, we end up with 3 ln of 1.9 times x, and then basically minus ln of 1.9, right? So just distributing across. Now we want to get things with x's on one side and the numbers on the other, so I'm going to go ahead and bring this guy over and bring this guy over, right? So switch those positions. So we'll have 2 ln of 0.4. When the negative ln 1.9 comes over, it becomes positive ln of 1.9, right? That'll be equal to 3 ln of 1.9x minus ln of 0.4x. Now from there we can factor out the x that's common on the right-hand side to both terms. So we pull that out, we have 3 ln of 1.9 minus ln of 0.4. And that'll be equal to 2 ln of 0.4 plus ln of 1.9. And then finally divide both sides by 3 ln of 1.9 minus ln of 0.4, 3 ln of 1.9 minus ln of 0.4. All right, when you divide that off, you end up with x is just equal to this rather unattractive answer, but certainly the right answer. All right, and finally, our last little example here, example D. To do this one, you'd want to take the ln of both sides again, because you're not going to be able to get e and pi into the same base. And if we do the ln of e x plus 5 is equal to ln of pi to the x power, we can then bring these exponents out in front, right? So when we do that, we have x plus 5 times the ln of e is equal to x times the ln of pi. Now here's the thing, ln of e is just 1, right? Remember, ln of e is basically the same as saying log of e base e, and remember that's saying what power do you need to raise e to end up having e? Well, of course the answer is just 1. So ln of e is just 1. So we can change that to 1, or in other words just 1 times x plus 5, or x plus 5 is equal to x times the ln of pi. Now from here we want to get the x's together, so we're going to subtract x from both sides here. So we end up having 5 is equal to x ln of pi minus x, and then we'll factor out the x that's common to both pieces. So we'll end up having x outside, leaving ln of pi minus 1, right? And then finally, to finish solving, you divide both sides by ln of pi minus 1. So that gives you your answer for x.